Hello, in today's session we will discuss the oblique condition, projection of the oblique condition of a line. That means when a line is placed in an oblique orientation in the first quadrant. Now in the last session we had a discussion, or we have understood the three cases where the line was parallel to both the reference planes, the line was parallel to one of the reference planes and inclined to the other one, that is line parallel to VP and inclined to HP. And then the next case was where the line was parallel to HP and inclined to VP. Now by studying these three conditions, we have understood that when a line is parallel to a plane, we get the true length and true inclination on the same plane. That means the image on that plane. So that means what? When a line is parallel to VP, we get the true length and true inclination on the image of on the vertical plane. So that is that means the front view. So similarly, when a line is parallel to HP, so we get the true length and true inclination on the HP, that means in the top view image. So that is what we have understood. So now in this third, rather I'll recall it as the fourth case now. The fourth case, that means right now for us will be when a line is inclined to HP by angle theta, where this theta is the true inclination of the line with horizontal plane, and as well it is inclined to VP by an inclination phi. So phi is the true inclination of the line with the vertical plane, and this condition, that means when the line is inclined to both the planes, is called as the oblique condition of the line. So it is the oblique condition of the line. What does that mean? Oblique condition means when the line or the object is inclined to both the reference planes, that is HP and VP. Let us say the length of this line is, so we can assume whatever this line is, we can name that line is some line, let us say AB. So this is some line AB, now which is having a length L, and it is inclined at theta to HP and inclined at phi to VP. Let us try to see how we get the projection of this line in this kind of oblique condition. So say this is the vertical plane, and this is the horizontal plane, right? So the intersection of the vertical plane and the horizontal plane is the reference line XY. So this is the vertical plane where I will get the front view image of the line. This is the horizontal plane where I will get the top view image of the line, and the condition of the line is such that it is inclined to, so both the reference planes. So I will show it somewhat, say like this. So we have named this line as say AB. So it is inclined to VP by some inclination phi, and it is inclined to HP by some inclination theta. So it is inclined to both the reference planes. That is what is mentioned. So let us take our line and understand the condition. So the first condition, if you remember, line parallel to both the reference planes was this. Line parallel to VP, inclined to HP. I come back to the first condition. Line parallel to again both the reference planes. Now line parallel to HP and inclined to VP was the third condition we have seen. Now our condition is that the line is inclined to HP as well as it is inclined to VP. So as if this point, this end is my reference end. So if I rotate this line like this, so now it is parallel to both the reference planes. Have a look at it here again. The line is inclined to HP as well as it is inclined to VP. So if you see in this condition, every point on this line is at a different distance from VP, right? Similarly, every point on this line is at a different height from HP. So obviously these two images what we will get, they will be also reflecting the same relation in the image. So what do? We go for the two images. One is the front view image when we look at it from the front. Second is the top view image when we look at it from the top. So let us take the first image as the front view. So what we are going to do, we will pass a projector through A. So wherever it will meet the horizontal plane, we will get, the vertical plane, we will get the front view image of A as A dash. So A is at some height, let us say H. Fine. But in this case, the line is inclined to HP. Then definitely height of B is different than height of A. So now we will pass the projector through B. So it is going to meet somewhere on the vertical plane. So there I get the front view image of B as B dash. But the height of B will be something other than the height of A. So I will get the front view image A dash B dash may be something like this, which will be definitely inclined to the reference line XY. We'll talk about the inclination afterwards. Right? Let us try to understand the image first. So then for second view what we are going to do, we'll drop the projector for A. So I get the top view image of A as A somewhere here. Now A is at say B millimeters from the vertical plane. But the line AB is inclined to VP. So B is at a different distance than A from VP. So when we drop the projector for B, so maybe somewhere here I am getting the top view image of B. So when I join AB, I will be getting, say B will be at different distance from, say it is B1 and this is B. So again I will get B at some inclination to the XY line. So that is how we will be getting image of an oblique conditioned line when the line is inclined to both HP and VP. Let us see how we get this image in orthographic projection. Right? So this is the reference line XY. Fine. So there are 2 points A and B. So there will be two projectors. So let us say this is projector for A. This is projector of A and this is projector of B. Now we'll apply our common sense, and what does it say? When the line is inclined to HP, the heights of A and B will be different. So maybe this is height of A, so this is A dash. And height of B will be something other than A. So definitely it is, say, B dash. So I'll get the front view image of AB as A dash B dash, which will be certainly inclined to the horizontal, that is reference line. Right? Similarly, now we will talk about the top view. For top view, A is at, let us say, B distance, B millimeter distance from the XY line. So this will be top view of A. But as the line is inclined to the VP as well, so distance of A from VP and distance of B from VP will be different. So maybe let us say the distance of B from VP is this. So I get the top view image of the line. So this is the front view image and this is the top view image. So I am getting both the front view and the top view of images of this line to be inclined to the XY line. Right? Now, again, let us talk about the length. So, if this is, say, B is length L, right? B is length L. Now, the image is on the vertical plane. That means the image is parallel to VP, right? It is on VP. So, image is on the vertical plane. So, image is parallel to VP. Now, for the front view, the projectors are perpendicular to VP. That means the projectors are perpendicular to the image, right? But the line is inclined to VP. That means the projectors are inclined to the line. Fine? If it is the case, that means it is not the same front view length which has been projected into the image, or the true length which is not being getting, it is not L which is being projected on the front. So here the front view length is certainly not equal to the true length. Rather, the front view length will be of course less than the true length. Same case will be with the horizontal plane. As the line is inclined to HP, the image is on HP, so image is parallel to HP. So the projectors are perpendicular to HP, but the line is inclined to HP. Projectors are this way. That means the projectors are inclined to the line. That means again in the top view, the top view length is definitely not equal to the length L. So which is so this top view length will be certainly less than the true length. That means here also we are getting the top view length to be not equal to the true length, or definitely the top view length will be less than the true length. So what is happening here? We are getting both the lengths to be projected lengths, right? Now if these lengths are projected lengths, that means certainly these inclinations are also not the true inclinations theta and phi. Rather, they are called as alpha and beta. Now what is alpha? Alpha is the projected inclination of the front view, and beta is the projected inclination of the top view. I hope this is clear. So now in this condition, in oblique condition, we are unable to get the true length and true inclination. Now with the help of the earlier cases, the 1, 2, 3 case we have seen, we can now very well determine what is the true length and the true inclinations of this line with the HP, that is the horizontal plane, and the VP, that is the vertical plane. So let us try to work out how we can determine the true conditions of a line if the projected conditions of the line are known to me. Right? So before moving to that, let us just go through the nomenclature what we follow in first angle. So when we are writing in capitals, right, this is the true condition. So whenever two true conditions are referred, they are referred in capitals. So if length AB is equal to, it is given in capitals, so that means it is the true length of the line. Then smaller case, this for example, I am taking name as AB, it can be PQL, whatever name given. So if it is A dash B dash, that means if we are talking about the front view of that particular image. If it is just smaller case, then it is the top view. We are referring to the top view conditions, right? Then theta. Theta is the true inclination of line, or for that matter when we move on to planes and all, it will be inclination with plane. So true inclination of line with, or it is the true inclination for that matter of the object with horizontal plane or the HP. Then phi, it is the true inclination of the line with vertical plane, VP. Alpha, alpha is the projected inclination of front view image, right? Beta is the projected inclination of the top view image or on the top view. Again here one thing which I have missed, that is if it is A double dash B double dash, that means smaller case with superfix double prime. So this is for the profile view or the left hand side view. I am mentioning left hand side view because in first angle method, until and unless it is mentioned, we will always go for the left hand side view. So if it is a profile image, the notations will be as this. So these are the notations which we will be always following to determine or when we are doing the orthographic projections, right? So now let us see how we can determine the true conditions of a line. How we can determine the true conditions of a line when the projected condition is known to me, or when the projection is known to me, or if I know the conditions of the line, I can get the projection. So what we are trying here right now, to get true condition of the line when the projected conditions are known or they are maybe given. So if they are given, how we can, so let us say some data is given to me and we, so this is the reference line XY. So we will consider that there is line AB whose projected conditions are known to me. So this is projector of A, this is projector of B. So this is height of A, this is width of A, this is height of B, and this is width of B. So let me mark it this way. So this is A dash, this is A, this is B dash, this is B. So the front view is known to me and the top view is known to me. So as it is suggesting that these are the projected conditions. So this is alpha, the projected inclination of the line in the front view, and this is beta, the projected inclination in the top view. So this is the front view length, which is not the true length, and this is the top view length, which is not equal to true length. So let me mention it right now here just for the understanding. But when we are drawing problem, we never mention it this way. We can just mark the dimensions which are given. So now, so this line is inclined to HP and this line is inclined to VP. Now we have studied the three conditions and we have understood one thing. When a line is parallel to a plane, we can get the true length and true inclination on the image of that condition, right? So now when we are working out here, we don't have the line. What we have are the images. So we have to play with the images, right? Applying logic. So when this line is inclined to HP and it is inclined to VP. Now if I want to see the true length of this line in the front view, I can see it if I make this line parallel to VP, right? So if I hold this line here at A, now holding it means if I have complete information of A, so I can take the end A as the reference. So if I hold this line at A and rotate it and make it parallel to VP, so in this state I will be able to see its true length in the VP, right? Now when I am doing so, I am not changing its inclination with HP, right? So now have a look here. Let us say this palm is the top view length of this line. So if I rotate this line, the top view image of this line is going to rotate with it, right? And we have also understood if a line is parallel to VP, then its top view image will become parallel to the XY line, right? So here we don't have the line, but we have its images. Now the thing is very simple. If I make this line parallel to VP, its top view image is going to get parallel to XY line. Or I can think it in other words, if I rotate the top view length and make it parallel to XY, that means in this condition, the line has become parallel to the vertical plane, right? So what I can do is, A as center and AB, the top view length as the radius, if I rotate it and make it parallel to the XY line. So that means I am making this line parallel to VP. So let us say it is a new condition for B. So I name this point as B1, where it is the same top view length, right? Now keep another thing in mind. When I am making it parallel to VP, I am not changing its relation with the HP. That means height of the end A, it is not going to change. It is going to be at the same height. That means if I draw a line parallel to the XY line passing through B dash, this line will be the locus of B dash. It will be the height of that B dash for any condition of the line. Right? So that means now for the new condition, what has happened? B has come to B1 position and the height has not changed. So when I have rotated this, the top view image has rotated. So we have rotated the top view, right? And in this condition, I have projected it in the front view. So this is the new condition. Right? So in the new condition, when the line becomes or the image becomes parallel to XY, B, the height of B is not going to change. So B is going to lie on this projector, as well as B is never going to change its height. So that means this B dash. So now for B1, this is B1 dash is the new position. And in this position, if I join A dash B1 dash, this must be the true length condition of that line or true length image of that line. So here we have determined the true length and this true length inclination with the horizontal will be the true inclination with HP, that is theta. So we have used that fundamental of when the line is parallel to VP, we can see its true length in the front view. So what we did, we have rotated that line, made it parallel, and we could now see the true length of the line and true inclination of the line. Though we don't have the line here, we have played with the images. Now similarly, I can apply the same fundamental. So I come back to the oblique condition. Now if I want to see, now I have determined theta. Now my job is to determine phi, that means true inclination with the HP. True length we have already determined. So now what I can do, if I make this line parallel to HP, I'll be able to see its true length in the top view, and so as the true inclination with the VP, because inclination with VP will be visible in the top view only. Now again we apply the same logic. When I am making it parallel to HP, that means I am making the height of A dash and B dash to be same. So when I rotate this line and make it parallel to HP, so obviously its front view length, not the true length. The front view length also will get parallel to the XY line, right? And then I drop the projector in the same condition. So when now to make it parallel to XY, so A dash as center, A dash, B dash as radius, when I rotate it, right, and I make it parallel to the XY line or the reference line, so this is the front view length we have rotated. Now say this is the second condition I am putting, so I'll name this point as say B2 dash. So we have made it parallel to HP. Now when I drop the projector, right, so I drop the projector in this condition. Again, when I am making it parallel to HP, I am not changing its relation with the VP. That means B, whatever distance it had from VP, it is the same distance. So now I can draw the locus of B parallel to the XY line in the top view. So I call this line as locus of B. Now B is definitely going to lie on this line, as well as B is going to definitely lie on this projector of second condition. So from B2 dash I get this as B2. So AB2, when I join AB2, this AB2 again will give me the true length, and the inclination of AB2 will be the true inclination with phi. So in the front view I am getting the true length to be equal to A dash B1 dash in the front view, and the inclination of A1 dash B1 dash is theta, and the true length in the top view as well, this will be equal to AB2. So we have determined, and the inclination of AB2 with the XY line will give me the true inclination with the vertical plane. So that is how we will always use those basic fundamentals we have seen for projection of in the simplest condition, and we can work out, and we can in such way we can determine the true conditions of the line. So that is what we have seen. So one thing we have to remember always, when a line is inclined to a plane, its images will be inclined. When a line is parallel to VP, that means the top view image will come out to be parallel to XY. Or for that matter, I can say it in other words, if I see that the top view image is parallel to XY, that means the line is parallel to VP. If the front view image is parallel to the reference line, that means the line is parallel to horizontal plane, that means the true length will be visible in the top view, right? Again, we have another thing we have understood. When a line is parallel to a plane, we get its true conditions in the same plane. That means if a line is parallel to VP, the front view image will give me the true length and true inclination. When the line is parallel to HP, the true length and true inclination will be given by the top view. So when a line is given to me in the oblique condition, that is how we can work out. If I know the front view image or the front view length and front view projected inclination, I will rotate the front view length, make it parallel to XY, drop it in the top view, and I can get the true conditions in the top view. Similarly, when I know the top view condition, that means beta and the top view length, I will rotate the top view length, make it parallel to XY, and if I project it, I can get the true length and true condition in the front view. So that is all in this session. Take care all.